Can you see the presentation?
I can see the presentation.
All right, I guess we're set to go. We're recording. Everything's cool. We're going to talk about amateur radio safety. It turns out that amateur radio can be dangerous. It can kill you.
Especially when your wife finds your receipts.
Yes, that too. But there's electrical hazards also besides wives. You probably, if you really get into it, I'm going to tell you right now, it can be an expensive hobby. So having a separate little bank account isn't necessarily a bad thing. When you're working on a lot of equipment, it's not so much today. Older equipment, tube type, you had voltages in the 200-300, maybe higher range. So those were a lot more dangerous than the new transistorized stuff. However, you still have power amp, both tube and solid state, that have some significantly high voltages. The tube type, you're talking 3,000 or 4,000 volts. So you can get enough of a shock to kill you in some of those. A lot of the high voltage capacitors in them will maintain a charge for quite a while, depending on whether or not they have bleeder resistors to discharge. So one of the things that you always want to do, well, the main rule when you're working on anything, even in your house, if you were doing electrical work, always have one hand behind your back. Never touch something with one hand on something grounded and touch something else. It only takes a little over 30 volts and 100 milliamps to kill you. Starts your heart fibrillation. So when somebody was there to resuscitate you, you've probably bought the farm. When you do get a shock, your muscles will involuntarily contract, which sometimes helps and causes you to pull away from whatever you're touching.
Yeah, that's a lower voltage. A high voltage usually will knock you away.
A couple hundred volts will.
Yeah.
I mean, trust me, I know.
240 will.
Yes. It's like getting hit with a 2x4.
Yeah. I had when I was young and I was taking air conditioning and refrigeration. We actually had an instructor that was working on a heater, and he touched the high voltage wire with the top of his head and killed him.
Yeah, it can get you.
And he was been in the profession for years.
And those are all things that can happen at low frequencies, like AC house current or DC. When you get RF frequencies, you can get RF burns also, which don't take necessarily the same amount of voltage and currents, but and I haven't had an RF burn. I understand that it's something you really don't want to experience. And like I said before, it can cause heart fibrillation. So let me get these out of the way. What health hazard is presented by electrical current flowing through the body?
Delta.
Delta. In your house, you should have a 3-wire outlet where the third wire is a safety ground. And if you look at the actual wiring, that will either be a bare or a green wire. You'll have a white and a black, and the white sometimes is kind of an off-white, and we call that the neutral, which is connected to ground at the service entrance, nowhere else. And the neutral and the safety ground are never connected together except at the service entrance. The safety ground goes to a ground rod right at the service entrance. And that's installed by the power company or the electrician that hooks it up, actually.
Usually any colored wire you come across is gonna be hot. If you got a white and a green and a different color, red, or sometimes even the black.
Right.
Well, the black is, but
Yeah, on 120, you're gonna have a neutral and a black. If it's 240, you're gonna have a red and a black and a safety.
right.
Unless it's a 4-wire 240, in which case you also have a neutral. So you have two 120s or a 240, depending on, and that's like a range hookup. When you want to ground all of your equipment, especially equipment that's in a metal chassis. And normally those will have a ground lug on them that you can tie to a common single point ground. You don't want to daisy chain the grounds. You want to have kind of a star configuration where they all connect to a common point. Could be a plate, could be a length of copper pipe, something that's very low resistance that connects them together. It's preferred to use copper strap, but braid is fine inside. It doesn't work well outside because it can corrode because it keeps the water in between the braids. So outside, you either want copper strap or at least a heavy gauge wire to ground your shack ground to a ground rod right outside as close as you can. If you have any like power amplifiers or any other equipment, even if you're guitar player and you got a guitar amp, the preferred tube type, they're going to have high voltages in them. So you want any of that kind of equipment to have some kind of interlock. So if you open it up, it disconnects it, even if it's plugged in. And like I said, it's not a test question, but always keep one hand behind your back. Never touch things with both hands. This is kind of a thing of a typical house where you've got your power line coming into the service entrance and there's a ground rod that there's safety ground is tied to, and also the neutral line at that point. And if you got some hand over here in this part of the house and you put a ground rod down, it's your antenna. If there was a lightning strike, the only path, well, part of that current is going to go to ground at this point, but there's going to be a significant voltage at this point because it's going to have, and you're talking 10, 20,000 amps. Even if this is milliohms, you're still going to have significant voltage. It has to travel through the safety wire, the safety ground, and can get over here. So it's likely to take out most everything in the house that's connected to that safety ground, which means everything plugged in. So why this is called bad grounding is these ground rods should be tied together with a heavy ground wire. And depending on the distance, you should have a ground rod about every 10 feet. So that it sees a much lower resistance through this path than it does through that safety ground. And you don't want to not have the safety ground because that's not for lightning protection. That's for when the thing in your hand shorts out. And instead of going through you to ground, it goes through the safety wire to ground. So in the United States, what circuit does black insulation indicate in a 3-wire 120-volt cable?
Bravo.
Bravo. What is a good way to guard against electrical shock at your station?
Yep.
Okay, fuses or circuit breakers. Their purpose is to remove power in case of a short or an overload, so that you don't have a fire. If you didn't break the circuit and you've got all that excess current, things are going to overheat to the point where it can actually cause a fire. So the fuse is supposed to open up, or the circuit breaker is supposed to open at a certain current level to prevent that. You only install a fuse or circuit breaker on the hot conductor for a normal house wiring on 120 volts. On 240 volts, you would actually have two circuit breakers, one on the black, one on the red, because it's really two circuits. You never put the penny in the old fuse box. You probably don't remember fuse panels with screw-in fuses.
They're probably not old enough to remember that.
But that was the thing when somebody didn't have a fuse, they'd go put a penny in and screw the old fuse in, which would get the power back on, but you no longer had a fuse. So that's why you never replace the fuse with a larger value or a penny, because now you don't have any protection. What's the purpose of a fuse in an electrical circuit?
That'd be Bravo.
Bravo. Where should a fuse or circuit breaker be installed in a 120 volt AC power circuit?
Let's see. Yeah.
You never want to break the neutral side. Why should a 5 amp fuse never be replaced with a 20 amp fuse?
The 5 amp is rated to break at that whatever
At
you're
about
using.
5 amps, right?
Yeah.
Usually it's a little bit above that. It depends on whether it's a time delay or a fast flow fuse.
Yeah, it's Charlie.
Charlie.
Charlie,
Last week I had to replace fuses in my solar panel system at home.
oh yeah.
And they're time delayed fuses. You know what I discovered? Time delayed fuses are twice the cost of regular fuses.
Of course. So we have some chat here. What is this?
Oh, that's just me commenting like 5 minutes ago.
Okay. Okay. When you're working on a power supply, even though a lot of times, like if it's a amateur radio power supply for a transceiver, you're not looking at very high voltages except for the AC coming in. But the capacitors, the filter capacitors in the power supply can store a lot of charge for a while. Now, if it's properly designed, you'll have a bleeder resistor on the output, so it discharges it when it's not powered up. They can give you quite a shock, however, so you really want to make sure if you start working on something like that, or even a power amplifier or an old tube type radio, that the capacitors are discharged. A lot of people that do that kind of work make up a little shorting stick where you can tie it to ground, and it's like a plastic piece of PV pipe or something with a bolt or something on the end, so you can actually short those terminals out. You can also just get a voltometer and measure the voltage on the capacitors just to see that they're discharged. And like I said, always keep one hand behind your back. What hazard exists in a power supply immediately after turning it off? Okay. 12-volt storage batteries or car batteries. But nowadays, they're used a lot in amateur radio as a power backup for emergency purposes where you don't have AC power. So a lot of people will have a set of 12-volt batteries. Usually now most everybody's using lithium iron phosphate as opposed to a lead acid battery. But there's still a lot of lead acids around. In either case, shorting the terminals on one of those batteries can pull a significant amount of current. I mean, they're designed for heavy current discharge, enough that it can create enough heat in the battery itself to actually cause it to explode like a lead acid battery. I mean, you may have seen pictures or something in the car where
Yeah,
it blew up
if
because,
you've ever seen one blow up, you don't want to be around it.
and it's going to
I've seen
spew
that.
out sulfuric acid and pieces of lead.
Yeah.
And then the lithium ones are even worse if they go. Overcharging or rapid discharging, like shorting it out, can cause outgassing, more so in the lead acid where you're going to get hydrogen. So you've got free hydrogen coming out, and you got oxygen around it. So a little bit of heat makes it turn into water again, along with an explosion. Which of the following is a safety hazard of a 12-volt storage battery?
Bravo.
Sounds good. What hazard is caused by charging or discharging a battery too quickly?
Alpha.
Okay, so we learned electrical shock can cause damage due to heating of the tissue. We call that a burn. It can actually disrupt some cell functions if it's bad enough. In fact, for high enough voltage, it actually discharges the flesh. Just kind of vaporizes it. And lower voltage shocks will cause involuntary muscle contraction, which a lot of times will save you. Sometimes higher voltages, you're holding something, you're stuck to it. At the lower voltages, it tends to make you contract and usually jerk away. Not on purpose, but that's just the way it works.
That jolt will sure get your attention.
You want to use 3-wire cords. Older houses never had a safety ground. And a lot of times you'll find people, instead of having to put in the little adapter plug, will just change the receptacle. But it's not really tied to anything other than maybe a concrete block. So it's not really a safety ground. And it shouldn't be tied to the neutral.
You'll find that in a lot of these old houses, they still have that old wire, two wire. With
Oh, knob and tube? Oh, yeah. Everything should be connected to a common safety ground. Basically a star type configuration where you want to have everything about the same length. So if the ground system is at a raised potential, everything is at the same potential, so there's no difference. So you don't have any currents running between the pieces. And you want to have interlocks on any equipment that's got high voltage in it. Fuses are there to prevent an overload, and you only install them on the hot lead or leads. Like I said, on 240, you'd have, if you notice in your fuse panel, 240s are a double breaker. So there's one on the black, one on the red. Don't put a larger fuse size in. Just bite the bullet and go to the store and buy a new one. Power supplies can have a high voltage in the filter capacitors for a little while after they're turned off. And don't short out storage batteries.